Hi, I'm going to do activity 5. Please join me. As always, the objective of a video like this is that you can kind of follow along, maybe step by step. Maybe you can just watch it like it's an exciting movie. I'm not really sure that it's that exciting. Or you can do activity 5 and pay no attention to me at all. That's also fine. But again, it's going to be a bit more freewheeling because I'm just going to try and do the activity myself. First thing I'm going to do is look at the activity myself. So it's called Looking for Love, and it has 3 objectives. I see here it says use states to manage your program. Okay, reasonable thing to practice. Use functions to organize your program. Organization is good. And write a function with a parameter and a return value. It doesn't mention make an amazing program, but that's what we'll be doing. So let's look at the idea. Another simulation. So the simulation this time is going to be about love. So there's going to be a title screen. This is that whole idea of using states. When the simulation itself begins, there's 2 circles in darkness. They both move off in a random direction. If they touch, then that's love, and love wins in the end, finally. And if either one of them goes off the edge of the canvas without them ever meeting, then the simulation ends in a very sad story, because they didn't find love with each other. As always, lots of ways to do this. I'm very happy for people to kind of go their own way and make it, so long as it meets the brief. That's completely fine, and that you're kind of covering the sorts of material we're covering. I'm going to take it step by step myself. So first step is a fresh project. So let me download this fresh project, template p5 project.zip. I'm going to unzip it. This is a very standard process. We're pretty used to it by now. And it has ended up on my desktop. It's actually ended up as template project 2. I guess I had another template project there. That's slightly confusing. Because that's slightly confusing, I'm going to delete both of these folders and I'm going to unzip it again, just so I know I've got a fresh one. Fresh. Okay, there it is. I'm going to rename it to, 05 Looking for Love. I think that's what I was, how I was doing it. That's activity 5, Looking for Love. And I need to navigate to my Documents folder, GitHub, Cart253, Activities. Yes, I got the naming right. That's nice. And as always, I want to kind of register my project in my repository, so I copy that folder into the appropriate folder of my repository so that Git and GitHub can see it. So that's done. With that done, I can go to GitHub Desktop and commit this initial step that I've taken. I can say A5 because this is activity 5, started activity. Often in these videos I'm forgetting to show you the final commit. I do make a final commit and push, as you can see from my repository. I'm not very good about committing along the way because I feel like it's just one more distraction for you. So I tend to only commit at the beginning and at the end. That's not the best programming practice. It's much better to commit as you get each step done, ideally. And you could practice that. I just don't want to take the time to do it. That's really lazy. Maybe I'll try and do it in this activity to show you what I mean. Okay, so I started the activity. Commit. Step 1 is complete. I feel very good about myself. Okay. Make a plan. So again, go off-road if you want to. Plans are good though. There's sort of 3 basic things that I think about needing to do in this program. The first thing is kind of get everything organized, the very basic setting up stuff. So that would be, I need to, again, as always, create some variables. They're going to represent the circles. I need to set up my canvas in the basic way. I also regard the fact that the circles move off in random directions at the start. That's kind of a setup thing as well. So I'm going to give them random velocities in the setup function. And another kind of setty-uppy thing is just making the background fill in the draw function. So it's all set up. The next big part of the program is really the simulation itself, the circles moving and all of the kind of stuff that happens around that. So I want to get the circles moving and displaying before I do anything else. And then I need to start doing my checks, right? I need to check if either of the circle goes off the screen, because that is what I will need for the sadness ending of this simulation. I also need to check if the circles intersect. That's the love ending of my simulation. And once I've kind of written all of that code, I'm probably going to want to tidy up, or what is known as refactor. So I'll move all of that stuff into functions so that my code looks a bit better. And then my final step is going to be, I'm going to have my states, the title, the simulation, and then the love and sadness endings. So I'm going to do the standard thing. I'm going to create a state variable that checks for each of those states I'm going to add some more functions that handle the title and the two endings, and then I need to make the connections between the states so that in this instance we'll click to begin, so when we see the title we'll click and go into the simulation, and the simulation itself will link to the love and sadness endings based on what happens. So it's a reasonably complicated program, right? I mean, it's a pretty simple idea, but you can see there's a decent amount of thought that goes into structuring something like this. So let's do it without further ado. So first of all, we've got our setup tasks. The first one is that I'm going to create the objects. Okay, I've tried to write this activity so that you could read this and do the stuff, or you can also read this and get the kind of much more specific instructions. So first of all, I'm making variables that contain our circles. So there's a few things I need to know about the circles. I know that they have to move and they have to have a position and a speed and so forth. So they need velocity and position and speed. I also need them to kind of be positioned at the beginning so that they're not touching, because that would end in the love result right away. So they need to be separated some distance. And they shouldn't be moving until I tell them to move later on in setup. So I'm not gonna look at these. These are sort of more detailed instructions. I think I can do it from the initial instructions. So in Atom, I need to actually open my project, or I'm not going to be doing anything. So I need to go back to my Cart253 repository, go to Activities, and I need to open the folder 05 looking for love. Open. Hey presto, we have a place to do some programming. So I open my script, and voila, my template. Again, just to keep my screen a little less busy, I'm going to delete these comments, just because I'm probably not going to be doing a ton of commenting as I go along, although maybe I should try and do that as well. Okay, so I said I needed variables to represent the two circles, so let's do that first. You could call it lover1 and lover2 if you wanted to. Maybe that's better. Maybe I'll do that. No, I'll follow the instructions. So circle 1. And we know that circle 1's got all of our standard sorts of properties. We'll think about the x in a second as well. X is going to be 0 for now. Y is going to be 0 for now. I think I will change them later. What else did I need? I need a size. I'm going to go for the good old 100. It's going to need a velocity, which I'll start at 0. And a y velocity, I'll start that at 0 too. What else does it need? A speed. That can be what? What's that going to be? 3. Let's go crazy. So that's circle 1. If we're thinking about our canvas, I'm probably going to make it good old 500 by 500. So I know that I want my circles to be separated from one another. It probably makes sense to start them in the middle on the y-axis, but I'll have to think about the x. So let me just copy this whole circle and paste it in again and call it circle 2. So now I've got my 2 circles. They're identical to each other in most ways. That's how most perfect love matches work, right? There's a lot of deep truths in programming. But I want to think about where to position them on the x. I need them to be separated from each other so they're not overlapping. So I would probably make them like sort of 2/3-ish each. So that would be at 150 or 350. I could also work this out in setup and assign it kind of based on the width of the canvas. That would work too. In this instance, this is kind of good enough for this activity. Okay, so I've got my 2 circles. They're kind of ready to go. What was I meant to do next? I mean, I do specifically say 2/3 of the way along the canvas, so maybe I'll do that in a second. Create a canvas of whichever size you prefer in setup. Sure. What am I going to use? I'll use my good old 500 by 500. So create canvas in setup, 500 by 500, just because I like it. Now, this is where I could do some math, some nice little math to set those x positions a little bit more carefully. So I could say circle 1's x is going to be the width of the canvas divided by 3. That'll put it 1/3 of the way of the canvas. And I could similarly say circle 2's x is going to be 2 times the width of the canvas divided by 3. That's a better way of doing this, to be honest. I'm adding some spaces in here for some reason. This is actually calculating where they should be, which means if I change my canvas size later on, they'll still be kind of in a good place, whereas setting them directly up here was kind of a bad idea. So I'm actually going to say this is undefined and this is undefined. That way I know that I have to set them later on or nothing will work. And it means I know that, I know to look for this to set them correctly. Okay, so we've done a little bit of extra setup there to do a better job and a more kind of consistent job. Set up the canvas, start the circles moving, right, so they both need to have some kind of motion, and to do this, as we can see here, it says move in a random direction. So we're going to assign a random velocity that should be between negative speed and positive speed at the very beginning of our program. So we would do that in setup as well. So we will say circle1.vx is equal to a random number between negative circle1.speed and positive circle1.speed. Same thing for circle 2. Circle2.vx equals random negative circle2.speed and positive circle2.speed. Wonderful. You can see there's some repetition going on here, and some of these things are things that we might do differently when we know more about programming. But for now, there's only 2 circles. It's not that repetitive. It's certainly not a disaster. Maybe for now I should say position circles separated from one another, just so that I know that that's what I'm trying to do there, and start circles moving in a random direction. That's good. There's a bit of commenting, just so that we know what's going on. Okay, that's taken care of. And the final thing that I said I was going to do, it's kind of not, and it's set up in a way, it's this default thing that we do, right, is to fill in the background in our draw function. It is in the draw function, though it's not in the setup function. So just like usual, I'm just going to set a black background here at the top of draw, just because it's such a default thing to do. I think of it as being part of how I set up to make my project work. So now we've kind of got all of the pieces in place for our simulation of these 2 circles that move around on the screen to work. Currently nothing actually happens in this program because we don't display anything, we don't change anything. So currently our program, if we were to run it, which I should do now quickly, just looks like a black square because there's nothing happening. And I should quickly check in the console, which I'm doing. There's no errors, there's just this favicon thing that I don't need to worry about. So we've got a black canvas, but I know that behind the scenes there's a lot more work has been done than just that. So setup done, let's write the simulation code. So the first thing is something we're very familiar with, which is let's make those circles draw on the screen by changing their x positions by their x velocities and their y positions by their y velocities. And then we should display them. This stuff is so ingrained by now that maybe it's kind of overkill to talk about this, but let's do it anyway. So circle1.x equals circle1.x plus circle1.vx. So that means change its x position by its x velocity, so it will move horizontally. Same thing for y. Whew, typing, eh? It's a thing. I want to do exactly the same thing with circle 2. So what I'm actually going to do here, just for fun, is I'm going to copy those, paste them, and then I'm going to use the multiple cursor thing that Atom has. So I'm going to put one cursor in front of that one, but then I'm going to hold down the command key and click in front of the other ones here. You can see I'm getting more than one cursor. I think that it's control click on Windows. You can check that. It's called multiple cursors. So now what happens is I can edit at all of those cursor positions at the same time. So if I hit delete, all of the ones get deleted, and if I hit 2, all of them, they get 2 typed in there, and so that's now updated those 2 lines of code to update circle 2 instead of circle 1. That's just a helpful kind of little thing, right? And then I want to draw my circles on the screen, so I know I say ellipse, circle1.x, circle1.y, circle1.size. I could do the same thing with my cursors here if I wanted to. Duplicate that line, click with command click in the 3 spots where I've got the 1, delete, and press 2. Just a little piece of efficiency, a nice little shortcut. So with that, I should have the expectation that when my program runs, these circles are now going to update their positions, which means that they will move conceptually and draw themselves on the screen so that they will move visually. So what does that look like? Let's go look. There they go. Oh, God, tragic. That was a tragic love story. They moved diametrically apart. Each time I reload, oh, that would have been good. They would have fallen in love just then. But of course, the program doesn't know that yet. And each time I reload, beautiful, beautiful story. Oh no, tragic story. We see the circles choosing random directions to move off in. And that's because we set their velocities to random numbers in the setup function and then updated their positions in draw. Perfect, it's working. Like one interesting thing, just as an aside, this is actually kind of affecting, right? Like there's a lot of different love scenarios that are going on here. For instance, this circle, you know, it was trying to meet the other circle, but it moved too slow and the other circle was too fast, and so they'd never met. That one was like they hurried towards each other. It was like a torrid love affair, a more cautious love affair in this one. Gosh, that one's really, really sad. They're moving very slowly. They're never going to meet. And so on, right? It's all happening. Do you notice one thing that I'm noticing about this? They're always moving horizontally. They never seem to move vertically. That is a problem. There's something wrong with my program. That's a good thing to notice. So let's go and look at that. I've done something incorrect. You probably were screaming at me in the first place to notice what I was doing wrong. So let me have a look here. What am I possibly doing wrong? Well, I can see it. It's this, right? I got confused about how many circles I had, and I only started them moving in a random direction in the x direction, which is not actually going to be enough. So I actually need to also start them moving in a random y direction. So I can do that by just duplicating these lines and saying Vy instead of Vx. One interesting thing again about that mistake, though, I should say, if I reload now, is one good thing about them only moving horizontally is you kind of compressed the love stories that were being told into some quite interesting scenarios, whereas now that it's totally random, it's a little bit more difficult to read them as, well, that was a good one, as stories, because it's a bit more complicated. So there's trade-offs there. It's actually kind of interesting to have made that mistake. I like that. Okay, but let's continue. I mean, I said that the program was going to, oh, that was good, that was going to do random direction in x and y. So we're going to leave it this way. Okay, so we've made the circles move. We're very clever. I was probably not as clever as you in that instance. So check for either circle going off the canvas. So we do need to know if one circle goes off the canvas, that's one of the endings, right? That's the sad ending because they're never going to meet. So we need an if statement that checks, has either of them gone off the canvas? So let's do the most obvious way of doing this first. Yes, let's do the most obvious way of doing this first. So after they've moved, which is here, and let me just quietly write a couple more comments. Move the circles would be that stuff, and display the circles. You might be crying out now that I need to put these into functions. I will put these into functions shortly, okay? I'm just not going to do it now. Check if the circles have gone off screen. Have they gone off screen? Well, we know that if we're asking a question like that, we have to use an if statement. So what would our if statement be? Well, we know that circle 1 has gone off the screen if circle 1's x is less than 0, i.e. it's negative. That would mean that circle 1 had gone off. It's also true that they would have gone off screen, so we say or, if circle 1's x is greater than the width, it would have gone off the screen. Or if circle 1's y was less than 0, it would have gone off the screen. Or if circle 1's y is greater than the height, it would have gone off the screen. So that handles circle 1, but then we also want to check circle 2, so we have to do all of those same things again. So or circle 2's x is less than 0, or circle 2's x is greater than the width, or circle 2's, this is getting ridiculous, isn't it, is less than 0, or circle 2's y is greater than the height. And then we need the curly brackets. So it's a very long if statement. It goes all the way off my screen. It's kind of like, it's not a hard one in terms of what it's checking, but it's just a lot of different possible cases that you can have when you're checking whether one of two circles has gone off the screen. So for now, let's leave it like that. We can think about it later on if we want to make an improved version. If that has happened, then we know that we need the sad ending. But we currently don't have a sad ending, so we should just maybe make a note here, sad ending, just so that we know that's where the sad ending goes once we work out how to actually display it. So if any of these things are true about the circle's positions relative to the edges of the canvas, we would trigger the sad ending. So currently this is all we need for that moment. We're just kind of prepared for the sad ending. Okay. Obviously currently that also doesn't affect our program. You can see here I've given some advice here. We could also think about writing a function that takes a circle as an argument and returns true if it's off the canvas and false if it's not. That would be kind of fancy. I might do that at the end if I remember. Okay. For now I'll leave it just because I don't want to get bogged down in the details of that in the middle of things. That would be a kind of a refactoring step as well. Check for the circles overlapping. Okay. Because if they overlap, they've fallen in love. So, so we're going to need another if statement, of course, that checks is the distance between those circles small enough that we know they're overlapping. And from geometry in mathematics, we know that If the distance between them is less than their two radiuses, or radii if you prefer, that means that they're touching. That's just sort of a fact of geometry. So we're going to do the whole dist calculation. So let's do those steps. So check if the circles overlap. So the first thing we want to do is we want to calculate the distance between the circles. So we're going to have a variable that contains that distance, and we're going to use the dist function to check it. And we know that the dist function wants the positions of the two things you're comparing. So circle 1.x and circle 1.y is the first position. That's the first circle. And we want to know the distance between that and circle 2.x and circle 2.y, the position of the second circle. So that's the distance, and then we want to check that distance, so we're going to use an if statement, and we're going to say if d is less than what? Well, it's the two radiuses of the circles added together. So that would be circle 1 dot size, that's the diameter, so we divide by 2 in order to get the radius, and we add to that circle 2's size divided by 2. So that's the two radiuses added together. If this is true, it means that the circles are touching. That's what it means. That's geometry, my friends. And here we would have the happy ending, the love ending, right? So love ending. Love ending. Sad face for that one, I guess. Again, we don't have a love ending written anywhere, so we're just making a note here for the moment so that we know that, oh, well, we will need that at a certain point. Okay, so we've done that check. Okay, now we've got some refactoring to do. So we've got our draw function has gotten kind of, if we look at it, our draw function has gotten kind of busy. There's quite a few separate ideas. You can see the separate ideas actually from my comments. So I said we move the circles, we check if they've gone off screen, we check if they overlap, we display them. Those are 4 quite distinct ideas. They could all be functions and our program could be better organized. I'm just quickly checking what else I'm supposed to do. So that's these 4 steps here. So let's first of all, let's move those things. So this code here moves the circles. I'm going to cut that, and I'm going to write a function called move that does that stuff. And I'm going to write it underneath draw. After draw is closing curly bracket, I define a function called move by writing function, then the name, move, empty parentheses, it doesn't need any special information, and then the block of code in curly brackets just contains that code that I pasted in that used to be in the draw function. So now it's tidied away into its own function, and I'm just going to do the same thing for these other bits. So this checks if they've gone off screen. So I could call this check off screen, for example. I keep wondering how I'm spelling, whether I'm spelling off screen correctly, if it's 2 words or 1. Probably doesn't matter too much. Oops, I need to write function because I'm defining a function. By the way, I cut that code again, so I've got it ready for pasting, and I paste it in there. So now I've got a function called check off screen, and I paste it in the code that checks if they've gone off screen. This is a common sort of slightly boring process of refactoring, is just kind of cutting and pasting code into functions so that it's more organized. So let's check for overlap. So cut, check overlap would be a good name for that function, and I'll put that after check off screen. So function, check overlap, no parameters, paste the code in, and one last one of these, which is these 2 lines here, which is displaying the circles, so I'll call that display. Display. And again, I'll put that all the way at the bottom. Function, display. You can see, by the way, and I'll just paste them in, I'm kind of ordering the functions that I've defined in the order that I've called them up here in draw. That's fairly traditional, is to put a function directly after where it gets called. So because move is called first in draw, I put it closest to draw, below draw. Check off screen was the next one that gets called, so I put that one closest, as close as possible to where it got called, while respecting the fact that move got called before it. That's why they're in the order that they're in. That just makes them easier to find. Okay, so it's all in functions. Let's make sure it still works. No. A typo on line 53 I see over here from my error message. Let's go to line 53. 53 is here. Oh, you know, I didn't check whether my condition worked. I was just too confident. So somewhere in here I've made a typo. So let's scroll along. There it is there, right? Circle 2, Y, I forgot my dot. I didn't forget it, I just typoed it, I suppose. So save that, go back. Okay, and now my program is working again. There, missed connections, Craigslist. Bad luck on that one, circles. So now we've got a working program, everything's kind of in functions, and we have that nice situation where everything in draw is looking kind of good. We could actually also think about moving this stuff into a special kind of, I don't know, set up circles function or something if we wanted to. That could be a good thing to do. Maybe I'll do it anyway, just because I'm feeling generous. Set up circles. I cut that code again. I didn't delete it. Circles. And then I'll have a function here called setup circles. And paste it in. You don't have to do that. That's just suddenly I was like, oh, maybe that would be good. Now my setup function also looks kind of nice because it's only got 2 things in it. And the stuff that's specifically about circles is in a specific circles-oriented function. It's not the worst thing to do. Okay. Back to this. There's a 5th step. Move all of your simulation function calls into a simulation function. That's good. So yeah, that's a good idea. So right now in the draw function, like we know that there's going to be different elements to our program. These 4 things are all about the simulation part of our program, but we know that there's also going to be a title part and 2 ending parts. So it makes sense right away to just have a simulation function. Again, I cut that code. I did not delete it. So I'm going to define a simulation function right under draw, and the simulation function is the one that can kind of handle the different parts of the simulation. Move, check off screen, check overlap, and display. You can see how this is kind of getting more and more organized. So now the draw function is really neat. It just fills the background in. That's a sort of a default action, and then it runs the simulation. The simulation moves, checks whether they're off screen, checks their overlaps, and displays them. And you know, if I stopped reading there, I'd have a pretty good idea about how the program worked, but then I can go into the details, right? Because I've defined all of those functions down below. This is getting to be a very nicely organized program, actually. I feel quite happy with it. Back to the activity. Activity. All right, so we've finished the simulation. It works. But we need the states that are the different kind of possibilities, including the title. Because currently we can't react to the endings, for example, and we don't have a title. So let's add states. To add states, the first thing that we're going to want to do is have a state variable that can track which state we're in. And there we're gonna start with it being set to simulation, because that's the part of our program that works. But we're going to know that there's also title, love, and I guess sadness states that will be possible. And we're going to create that structure in our draw function that checks which state is currently active and is going to call, in this case, the only thing it can do is run the simulation function when that's relevant. So let's go and do that. So first of all, I want my state variable. So I'm going to put that at the top after my circles. Let's state. And I'm going to set it to simulation, like I said. That's the only state I really have right now. And I'm going to say can be title, simulation, love, or sadness. Those are my 4 states names. And currently it's set to this one. Then in draw, I want my big if statement that checks all of those different possible states. So if state is, I guess we'd do them in order. So title would probably be the first state. For now, the title doesn't exist, so I'm going to do nothing there. I'll just leave it blank. Else if state is simulation. What do I want to do in there? Well, I want to run the simulation. So I should move this function called simulation, cut and paste, into there. So if the state is simulation, then we do the simulation stuff. Else if, and then we're going to have our 2 endings, right? If the state is love, do something in there that's concomitant with the idea of love, and else if our state is sadness, I hope it isn't, but it might be, then we'll do something in there to handle the sadness situation. So now we've got this kind of structure ready, the basic kind of state-based structure. It's called, again, a finite state machine. It only can do one thing, which is run the simulation. But fortunately, we've set our state variable to simulation, so our program should just keep working, because draw is going to come to this big if statement. It's going to see it's not set to title. It is set to simulation, so it's going to do the simulation stuff. Let's make sure that that's true. It is true, right? So I reload it. It's in the simulation state, so it just displays the simulation. Whew, a lot of work that we're doing here, but that's good. Good. So now the final kinds of things I guess that we want to do is add those other states. So let's define a title function that displays the title. And we're going to do that by using text, because that's what all of our other states are going to be, is just text-based for now. So what are the things that we need to do? Well, the title function, when we call it, is going to be called before the simulation function in the order of our states. And in fact, let's just call it here, right? This is going to be the function that handles the title situation. So if the state is equal to title, then we're just going to call the title function, just like we would call the simulation function when it's the simulation. In order to call the title function, we actually have to define it. So as I've said before, I often call functions before I've defined them, just because that happens to be the order that suits me. There's no harm in it so long as you don't expect the function to magically exist. So we're going to define our title function, and what's it going to do? It's just going to display some text. So let's set a text size. That's a good amount of text size. We're going to need a fill, I guess. I'm going to make it white. I'm going to make it white. Maybe I should make it kind of pink or something. Let's try and achieve some kind of a pink. I don't know if that's going to be any good. A fill, sorry, talking to myself, and I'm going to set the text align to center center. It's possible I should do some of this stuff up in setup, but for now this is okay. And then I'm going to display the title text, which is going to be called love question mark, because it's a simulation about whether or not two circles fall in love, and I'm going to display it in the center of the screen. And that's what the title is going to do. It's just going to display some text. So this is what happens when the state is title, but right now the state is not title. So if I want the state to be set to the title, I need to change my variable up here to title. So that, and this is sort of appropriate because this is how the program should begin, right? It should begin in the title state and display the title until we're ready to start the simulation. So let's go look at that. Did it work? So love, it's kind of interesting, it's quite a nice effect, is being displayed at the bottom of the screen. That suggests that I've done something wrong with the Y location of my text. So let me go back and take a quick look at that. So back down into, and here's one of the advantages, right, of this function-y system, is I know that the problem is in here, right, in the title function, because that's what I'm looking at on the screen, and I can see that, yeah, I've specified height instead of height over 2 for its position. So if I save that, and now it's in the right place. Looks good. Looks very professional. So now we're in the sort of a good situation. The program starts and it's in the title state, and the title state calls the title function, and the title function displays the title on the screen. Love, question mark. Lovely. Haha, lovely, very good. Now that we've actually got a title state, we can now include that idea of switching between states, right? Because we want to be able to switch from the title state, which we see at the beginning, to the actual simulation itself. And we're going to do that with mouse pressed in this instance. So they press the mouse and we switch from the title state to the simulation state. So in mouse pressed, we're going to define mouse pressed. We're going to have an if statement that first of all checks, are we in the title state? Because we don't want to change based on a mouse press just any old time. It has to be that we're changing from the title to the simulation. If it is in the title state, then we can switch to the simulation state. So let's go and do that. So we need a mouse pressed function. Where would we do that? We may as well put it right at the bottom. There's no rules here necessarily, but because it's sort of a generic P5 event handling function, I feel like I want it to be at the bottom. So when they click the mouse, I know that I want to set the state to be the simulation, but I only want to do it if the current state, whatever is in the state variable, is the title state. So if the state is title and I just clicked, then I can set the state to simulation, causing the program to switch from doing the title stuff to doing the simulation stuff. So let's make sure that that works. So we're in the title state. Title is just being run over and over again, so it's just displaying the title. And if I click, ooh, that was an interesting little effect there, right? Both of the circles were pink, which I kind of like, but it's not what I intended. That was a classic case of the fill that I set for the text bleeding out and affecting the fill of the circles, which I didn't explicitly set. That's kind of not what I want. I have the kind of the functional effect there of my title transitioning successfully to the simulation, so that clicking thing worked. But let me just go and quietly fix the title just a little bit more. How would I fix that? The easiest way is I should push and pop around my title settings. And that keeps it all safe. So all of these settings here will not affect the rest of the program. Interesting little problem that I had there. An easy fix, but it's one of those things that happens, and it's good to be able to easily find where the problem is in this instance. In this instance, I guess I also just knew what kind of a problem it was. Maybe it wouldn't have been as obvious to someone else. Okay, so we've got the transition from title to simulation. My circles are white again now because of the push and the pop. So we're almost there, actually. And what we need now is the other two states. So we need a love function that will display the ending, the happy love ending. It's going to be very similar to title, right? Except that it's going to display a different word, I guess, maybe in a different color. And we're going to call that function in our big state machine, and we're going to change the state to be love if the circles overlap. So those are my 3 steps. So first of all, let's make the love function. Where should we put the love function? I guess we would put it after the simulation function. So we're going to call the love function here, right? It's the thing that's going to handle the love state. So if the state is love, we call the love function. Because that's after simulation, I'm going to put it here. So function love. What should the love function do? I'm going to be lazy, and I'm just going to copy the stuff from the title function, because I want to do something very similar. I just want to display some text. Instead of writing the word love with a question mark, I'm going to say love with an exclamation mark, because the circles met and fell in love, and that's a beautiful thing. And maybe, how am I going to indicate how wonderful that is? A slightly brighter pink color? Is that a sensible thing to do? I don't know. Let's try it. So a slightly brighter, I think, pinkish color to indicate the beauty and success of love in this instance. And otherwise, it's the same idea as the title. Just this function will just display the word love with an exclamation mark to indicate that they met and they're in love. So that's what the love function does. It's called whenever the state is love. But for that to be relevant, we need the state to be able to become love. And now we can return to our simulation stuff in particular. And we know that we wanted our love ending in the check overlap, right? When we checked if the distance between them was small enough that they were overlapping, we knew that we wanted to trigger our love ending, but we didn't have a way to do it back when we were writing that code. Now we do. We trigger the love ending by setting the state to love, and that will mean that in draw, it will switch to that part of the if statement that calls the love function. I guess we can go and look at this now and see if we can get a love connection. Oh, good grief. That was very unfortunate. Let's reload. Nope, that's not going to work out. Reload. Oof, no. Oh, God. Yes, they made it. Thank goodness for that. Love is victorious. Quite satisfying. I'm pretty surprised by how much I'm liking this. I hope it's not embarrassing that I like my own program. Okay. Now we're just going to do kind of exactly the same thing except for sadness, right? The sad ending. We're going to handle it in the same way. We're going to go find our love function, which is here. I'm just going to copy the entire thing. Copy the whole function, paste it in underneath. We need to change its name. We can't forget that. We can't have 2 functions called love. This one's going to be called the sadness function. And what's the text going to be? I'm just going to have a sad face, like a very sad face emoticon. Is that an emoticon? Yeah. And probably a different color. I'm going to make it kind of an icy blue, so more blue than the other colors. That is the color of sadness, right? Otherwise, I'm going to keep... You can see that I'm kind of, because I'm repeating this text size and this text align, that suggests I should be doing that up in setup. But I'm aware that I've taken quite a long time to run through this exercise, so I'll leave that alone for now. So I've got my sadness function. I made it. A very big mistake I could have made is I could have forgotten that I don't call it yet. I have to remember to call it up here, sadness. Otherwise, it would never happen. So if the state is sadness, so it's not title, it's not simulation, it's not love, it is sadness, then I'll call the sadness function to display my sad face. And now I need to, again, make it happen. So I need to head back down to where the code is that triggers the sad ending. There it is there. I put that little placeholder comment, which was pretty helpful. I check off screen, and if one of the circles is off screen, I get the sad ending, and I trigger the sad ending by switching the state over to sadness, just like that. If we go take a look at the program now, we click to begin. Oh, so sad. And we get the sad face. That font is not great for displaying that sad face emoji. Could rotate it, I guess. I'm actually just going to quietly go and where is it? Where's my sadness thing? There. I'm just going to make it a standard sad frowny face. Maybe that will look better. These are the things. These are the important decisions. Much better. Okay, so that works well. So that is actually the total working program at this point, I believe. We've added sadness. Lovely. We're finished. There's a few other things that we could do. There's lots of improvements that we could make aesthetically, of course. There's a few places where we've got strings for the title and the sad ending and stuff. They maybe could be variables. That would be good. One of the big things that I said I would consider, which I guess I'll do now, you can switch off now if you're not interested in this, but I said that I would look at a kind of better way of doing this giant check. This is actually relatively sophisticated, I guess. I'm not sure. You see what you think. So what I could do instead of checking literally everything along here is I could do something at least slightly simpler, which is that I could have a function, and it could be called isOffScreen. So it's something that checks if something is off screen. And the thing that it checks is a circle. So that's the parameter that it's going to take. Now note that this is not specifically circle 1 or circle 2, it's just a circle that it's going to be told about when it gets called. And then what is it going to do? Well, it's going to do something pretty similar to up here. It's going to say if the circle that I'm being asked about, if its x is less than 0, or its x is greater than the width, or this is, and you can see that this is not totally dissimilar to the code above. It is a bit shorter. If one of its positional properties is off the canvas, we're going to return true because it is off the screen, and otherwise we're going to return false. We as in we the function, because I guess we think about ourselves as the function while we're writing it. So this is a very nice function because whatever circle we ask it about, it can tell us whether that circle is off screen. And so what we can do is we can ask it, is circle 1 off screen, and then we can ask it, is circle 2 off screen. And so instead of this extremely long condition here, what we can say is if is off screen circle 1, so that will tell us whether or not circle 1 has gone off the screen. That's one of the things we care about. So instead of writing out all of the stuff for circle 1, we just handle it inside our function here. Or is off screen circle 2, then we go into sadness. So again, the good thing about this function is that it's made our program much more readable. Now it just says, basically, if circle 1 is off screen or circle 2 is off screen, then we go sadness. And then that function is off screen handles the generic case of a circle, checking whether any circle has gone off the screen. And it does this by checking whether any circle's x or y has gone off the canvas, right? I keep saying screen. I really probably mean canvas, but it's okay. It doesn't matter whether we give it circle 1 here or circle 2 here. It's going to check the x, the y, and compare it to the height and the width, etc., and return true if it is off the screen and false if it isn't off the screen. The result of this is the same, right? If we go back to our program and run it, well, they fell in love that time. It was very beautiful. But that time they didn't. Same result, right? It still just checks, did the circle go off the screen? It's functionally the same. But it looks nicer. We've compressed down particularly this conditional check here to something that's much more readable and offloaded the work of checking whether a circle is off the screen to a function that returns whether or not it is. So it's a good use of functions there. Okay, just in case you were interested in that. So that's another nice little piece of tidying. There's more stuff that you could do, of course. And as I predicted, I have completely forgotten to do anything in here of use, committing each step. I'm glad I didn't because it would have taken even more time. So I'll just say that I finished that activity and push. Goodness me. Okay, so now we've got a little love simulator. It's better than I thought it was going to be. And in fact, I'm quite happy with it. And that is me doing activity 5, looking for love. See you next time, kiddos and adultos and all age ranges. There is no discrimination coming from me. Stop recording.